All right, so you've seen this exponential growth equation many times. So let's talk about when you have a half-life. So a half-life means after m number of years, so it's not in that formula, but m number of years, half of it is gone. So y sub 0 is the original amount. So we're going to use this equation and we're going to put in t equal m, and that the amount is 1/2 of the original amount. So instead of y, I'm putting in 1/2 y naught. And then instead of t, I'm putting in the m, because that's what's happening. Half of it is gone after m years. So if I divide both sides by y sub 0, because it's a quantity, it's not 0, it's an amount, so I can divide through, I get to here. So now I want to solve for e to the k. So we're going to become better mathematicians this year, so I want you to get used to solving for e to the k, not k. So that means I'm going to take the 1 over m power of both sides. So if I take the 1 over m power of both sides, these two multiply, so that's how I get e to the k. So this gives me 1/2 to the 1 over m power. So now put that back in. So put this 1/2 to the 1 over m power back in here for e to the k. And so I get 1/2 to the 1 over m, all to the t power. You multiply this exponents, and so I get this. So this is the formula for half-life that I'd like you to memorize. Half-life always has the number 1/2 in it. M is always the number of half-life years. Y sub 0 is the quantity that you started with. Let's dig in. All right, so I have 100-gram sample, so that is my y sub 0. And it has a half-life of 1,200 years. So right away I know I have 1/2 to the t over 1,200. All right, how long does it take to decompose to 20 grams? So 20 equals this. So now this is where I need to solve for the t by taking the ln of both sides. So if I divide through by the 100 first, so I get 1/5 equal 1/2 to the t over 1,200. Then I'm going to take the ln of both sides. So I have ln of 1/5 equal ln of 1/2 to the t over 1,200. So ln of 1/5 is equal to t over 1,200 ln of 1/2, and then I'm going to multiply by 1,200, and I'm going to divide by 1/2. ln of 1/2. And that would give me the number of years that it would take to decompose to 20 grams. Let's try it again. All right, so how long will it take a sample? Ooh, they're not telling me how much, so I'm just going to leave it as y sub 0. So leave it as y sub 0, 1/2 to the, it's telling me I have a half-life of 900 years, so I have t over 900. All right, how long is it going to take to decompose to 75% of its original amount? So you know that means 75% of your original amount, and it's starting with the original amount. All right, so I'm going to divide through by the y naught. So again, it's a quantity. And then I'm going to take the ln of both sides. And the reason I'm taking the ln is so that exponent will come down, because that's what I'm trying to solve for. So ln of 0.75, t over 900, ln of 1/2. So 900 times ln of 0.75 over ln of 1/2 equal t. All right, so let's see. You've got another one that's got 60% of its original amount that's left, and find out how old the sample is, and they're telling me the half-life. So y equal y naught, and then 1/2 to the t over 2,300. So that's going to be, I'm going to be finding out how long it takes to get to 60% of its original amount. So 0.60 of y naught 1/2 t over 2,300, divide through by the y naught, so I get 0.6 is equal to this 1/2 t over 2,300. Take the ln of both sides. This t over 2,300 will come down in front. So solving for t, I get 2300 times ln of 0.6 divided by ln of 1/2 is equal to the t. And these are fine answers. You don't need to go put them in your calculator. All right, so let's move on to Newton's law of cooling. I'm not going to develop how this formula came about, but T sub 0 is the original or the initial temperature. T sub S is your surrounding temperature. So it matters what your surrounding temperature is. So your cup of coffee cooling here in San Diego is different than a cup of coffee cooling at the North Pole. All right, so again, go solve for the e to the k first, not k. Okay, not k. All right, before you go answering the question. So here we have a soda that's 72 degrees. So that's your initial temperature, 72. It's placed in a 44-degree fridge. That's the new surrounding temperature. So then they give you information. So this is the information that you will use to solve for e to the k. So even before you go to the question, go solve for e to the k. So after half an hour, so t is equal to, you get to choose how you want to do it. I'm just going to choose 30 minutes. T is 30 minutes. The temperature is 61. Okay, so let's go put everything into my formula I've got memorized here. So T is 72 minus 44 e to the k times 30, putting in the 30 minutes, plus my surrounding, which is 44, and I'm setting this equal to 61. So doing some arithmetic here, 61 subtract, whoops, whoa, go away. 61 subtract 44 gave me 17. And this is 28 e to the k times 30. So then I'm going to divide, and I'd prefer you not go figure this out, just leave it like this. Then again, remember you're solving for e to the k. So 17 over 28 to the 1 over 30 power. Now put that back in. So my temperature formula will be 28. Instead of e to the k, I'm going to put in this 17 over 28 to the 1 over 30 power, and that's all to the t. That's all to the t up here, so let me just emphasize it for a second and put the t, and then plus 44. Okay, so this is the same 17 over 28 to the t over 30 plus 44. Okay, so be really careful. So this number here will all many times match this number here, but you cannot cancel them because this one's contained inside this exponent, correct? All right, so now we're ready to answer the question. What is the temperature after another half hour? So that to me means time is 60 minutes. So the temperature at 60 minutes will be 60 over 30 plus 44, and you can just leave it like that. Okay, one last question here. How long does it take to cool to 50 degrees? Okay, so let me just write the equation that we developed down. Okay, so I want it to cool to 50 degrees. So I'm going to subtract 44, so I'll get 6. $30. Then I'm going to divide through by 28. T over 30. Now I'm going to take the ln of both sides. I take the ln to bring that t over 30 in the front. So I'm going to multiply by 30. Divide through. And that gives me the temperature. I'm sorry, the time to get to the temperature of 50. All right, some more things here. So I have hyperbolic trig functions. So our trig functions go off the unit circle. these hyperbolic functions come off of the hyperbola. So it's not going to be necessary for us to memorize any identities. We just get to know their derivatives. That's what I'm expecting you to know. So the derivative of sinh is cosh, like this is how you say it, sinh and cosh, so kind of like just the derivative of sine is cosine. The derivative of cosh is not negative, so it's a little bit different. Not much though. And then from now on, we don't say tan, ha, secant, shish. We say hyperbolic tangent, hyperbolic secant. So this is the same. So these are the ones that are different. So I put them over here. Oh, actually, just these two, right? Oops. This one's not the same. So derivative of hyperbolic cosecant is negative hyperbolic cosecant cotangent. So it's the cosine and hyperbolic secant. So anything that has to do with just cosine. Those are the two that are different in that they have this one has a negative and this one does not. So anyway, so you just need to memorize them. So if I want to take the derivative of this, I'd say, oh yes, that's negative hyperbolic cosecant squared, carry the angle along, and then take the derivative of the angle, which you know is e to the stuff times the derivative of stuff, right? The extra negative there. All right. Derivative of sinh is cosh, carry the inside function along, then take the derivative of sine, which is cosine, carry the inside function along. Oh my gosh. And then 3x squared. All right, so then take the derivative of hyperbolic tangent. It's hyperbolic secant squared, 5 to the cosh of x. Then I get 5 to the cosh of x times the derivative of cosh is sinh, and then times ln of 5. All right, one last one. So this one is negative. Hyperbolic secant, hyperbolic tangent. Whoops, meant to write that. And then I'm going to write this angle that I'm carrying along. Now I'm going to multiply by the derivative of the angle, and of course I see product rule. First d second plus second d first. Whew!